In this lecture, I would like to demonstrate the interconnectedness between several issues when it comes to sustainable development. This I would like to demonstrate through discussions of a case study on nexus between groundwater quality and sanitation. This study was carried out by Professor Ligi Philip and myself and was funded by Argyem Foundation. We do not have proper sewage treatment system in many places in India and elsewhere. In fact, improper or no sewage treatment systems in many places, not only in India, but in many other countries too. And in such situations, septic tanks and other on-site systems are commonly used for handling the waste from toilets. For example, here we show a septic tank, that is the waste from the toilet comes into this septic tank and then it gets treated locally there. And this is showing an actual septic tank here, and this picture shows the drawings of a septic tank. These septic tanks have to be constructed in such a way that there is no seepage of the wastewater from the septic tanks into the surrounding grounds, but many times they may not have been constructed properly, or many times people do not provide this bottom, impervious bottom to the septic tanks and let the seepage or the wastewater that can from the septic tanks can seep into the grounds. Like what we have shown here, you have a cluster of houses and all this waste from the toilets is taken to the septic tanks here, and if this septic tank is not constructed properly or it is not operated properly, then the leachate from the septic tank can go through what we call the Waddos zone first, and then it will go and then get mixed with groundwater and then contaminating the groundwater. So, your surface sanitation conditions are linked to sustainable maintenance of water quality in groundwater sources. This we want to demonstrate, and we have done this particular work, and then that is what I am going to discuss. Like 60% of the districts in India, we have problems related to groundwater availability as well as groundwater quality, and we have to protect the quality of these groundwaters if we want to use them for any domestic purpose or any other purpose. And so, the prevention and remediation of groundwater contamination is very essential, because it is a major source of domestic water. So, in this particular case study, before we started, we had certain hypothesis, that is open defecation, which is quite common in many places in India, causes more groundwater contamination. Deep aquifers, that is if we have groundwater table very much below the ground level, those are deep aquifers, are relatively free from pathogens, because even if there is a seepage of wastewater from the septic tanks and other on-site systems, on the way there is a filtration action of the soil might prevent pathogens entering into the groundwater bodies. Design of septic tanks can be modified to improve the treatment efficiency. That is, we can modify the design of whatever the conventional septic tanks, and we can improve the treatment efficiency, and groundwater can be protected by installing properly designed septic tanks. These are the hypothesis we had, and then we will see what we have found out. So, we had taken 3 towns in Namakkal district in Tamil Nadu, that is Namakkal town itself, and then there is another small panchayat town, that is Ermaipatti, and another small town Mohanur, which is very close to actually the Kaveri river. And the Namakkal town, we had a population of 55,145 and as per last census, and then Irmaipatti we had 12,085 persons. In Namakkal town, 100% of households surveyed had the toilets, but then 100% usage of these toilets is little doubtful, because we also could find some open defecation areas. They do have septic tanks, but then the design of these septic tanks is also doubtful, in the sense whether these septic tanks had impervious sides and the bottom, that we are not sure. In fact, many of the septic tanks had pervious bottoms and then allowed seepage of wastewater into the soil and eventually to the groundwater. In Erumaipatti, 64% of the households that we surveyed have septic tanks. Again, their design is little doubtful. So, and the geology of the area is, it is a hard rock area, and this both here Namakkal as well as Erumaipatti. Erumaipatti had hornblende biotite gneiss, and then Namakkal had charnockite, and they had a weathered rock up to 30 meters. The top 1 to 5 meters is soil, then we had weathered rock, and then of course we had fractured aquifer, and groundwater level was almost 10 meters to even more than 100 meters. The groundwater level was higher in Namakkal town, whereas the groundwater level was very low in Erumaipatti. So, that is what I mentioned about the geology of the area, which is very important for studying the nexus between the surface sanitation conditions and the groundwater quality. So, we have chosen about 36 wells which are already existing for monitoring. We have also constructed 6 new wells as part of our study, and we had carried out groundwater monitoring by collecting samples from these 36 plus 6 42 wells, and we had done it over a period of 2 years and 6 times, and the dates when we had taken the samples is given here. And we had taken these samples and then we have analyzed for the groundwater quality. And the way we have chosen these wells which we have monitored is like, we have to bring out the effect of nature of sanitation conditions, such as whether the well is very close to a household which is having septic tanks, proximity to public toilet systems, whether the well is located in an area where open defecation is practiced, or location with significant open drainage systems, and in these 2 towns we had found lot of drainage system which is not completely impervious, and then the drainage system itself was carrying lot of wastewater that is coming out of the toilets, and location with open drainage with no open drainage system, but concentration of many septic tanks, and then proximity to contaminated surface water bodies. There were some few tanks and lakes which actually were receiving partially treated wastewater from a sewage treatment plant, and then proximity to composting sites or solid waste management sites, proximity to sewage treatment plants, and then we also made sure that we sampled both open wells and bore wells, and we were conscious about how much of aerial extent that we can cover through our sampling within each of these things. And of course, when you chose these monitoring wells, you also have to worry about accessibility. That means we can reach these wells easily, and then we can make the measurement sampling in a easy way, ease of collecting samples and measuring water table level. So, I have showing you some few pictures of our sampling. There is one groundwater, a bore well which was located very close to the toilets and improper septic tanks, and there is a bore well which is located to an area which is nearby an open defecation that is being practiced in this area. Although they had a community toilet, for some reason because of availability of water and other problems, people were practicing open defecation here. So, we had a bore well located, and then we took samples of water from that and analyzed. And then we had an open well which is located very close to a solid waste dumping yard, or it is actually a compost yard, not the dumping yard, compost yard, and then there is an open well. Like this, we have chosen 36 wells, and then we have taken samples, and then we have analyzed them for different water quality parameters. This picture shows, like in Namakkal town, where all we have the our sampling wells. I was telling about, this is the lake which is actually receiving a the treated, or the partially treated wastewater, and then this and we had some wells around that, and then we also had another solid waste dumping yard, and then things like that, and some wells were chosen close to that. And in this is the Erumaipatti. Here we had 12 existing wells, and then we also installed 3 more wells for monitoring. And we also measured depth to the water level in these wells, and then we had done this on 6 times in October 2016, November 2016, then December, and then January, February and March. And then we can see that many of these wells in Erumaipatti, that is this is the region where the groundwater level is almost 100 meters below the ground level, whereas in Namakkal town only in some wells it is going below 60, otherwise it is up to about 20 to 40 meters, because this the groundwater level does affect the quality of the groundwater, the quality of the groundwater as affected by the surface sanitation conditions does depend upon this groundwater level. And what are the results we got? For existing wells, FC is the fecal coliform, and as I mentioned, we had taken the samples on December 2015, April 2016, June 2016, December 2016 and March 2017. The permissible value for fecal coliform is absolute 0, but you can see that the concentration of the fecal coliform is as high as 6, in some instances 600 CFU per 100 ml, when it should be actually 0. And another interesting thing is, all the wells in Erumaipatti, the 12 wells in Erumaipatti and then 4 wells in Mohanur, all the wells are contaminated by this fecal coliform, irrespective of where they are located, irrespective of what is the surface sanitation conditions close by that close to that well, whether they are open wells or whether they are deep wells or deep bore wells, or what is the water level in the what is the water table level in these wells, irrespective of that, all the wells are contaminated by fecal coliform. In this is in Erumaipatti and Mohanur. And similar results we found for the existing wells in Namakkal town. Here also, in fact, in Namakkal town, in some of the wells the fecal coliform concentration goes as high as 1600 CFU per 100 ml, and in fact these are the wells which were very close to the solid waste the compost yard. And again, all the wells, whether they are bore wells or the open wells or where they are located, all the wells have shown the the presence of fecal coliform in the groundwater. And if you compare the concentrations of fecal coliform in Namakkal town with respect to the concentrations of fecal coliform in Erumaipatti, in general the concentrations in Namakkal town are more than the concentrations in Erumaipatti. Same thing, not only fecal coliform, in fact we had done this analysis for many other parameters. Here I am showing with respect to ammonia. So, ammonia is also found more than 5 milligrams per liter in all the wells in Ermaipatti and Mohanur, and in Namakkal town also it goes as high as 140 and 120 to 140 in some of the wells, and in general it's about more than 5 in many wells in Namakkal town. We had done the analysis for nitrate too, where we are showing this 45 milligrams per liter is the allowable limit, and in some of the wells it is more than that 45, and in many other wells there is a presence of nitrate in existing wells in Ermaipatti and Mohanur. And the same thing is true for the concentrations of nitrate in wells in Namakkal town. Here again many wells the concentrations are can go more than 45 milligrams per liter. These figures are showing for all the 6 samples in each of these wells. So, what are the key findings as far as the groundwater quality is concerned? Very high levels of fecal coliform, total coliform, ammonia and nitrate. It indicates that the groundwater contamination is coming from improper sanitation, and all the wells are contaminated by fecal coliform and total coliform, which means that the groundwater contamination, all the wells wherever they are located, they are contaminated. So, it indicates that groundwater contamination is not only due to septic tanks, but also due to all other poor sanitation conditions. As we have shown earlier, the wells, the bore wells located close to the place where they had a solid waste the management yard or the compost yard, that showed very high levels of the contamination. Another interesting fact is both shallow wells and deep bore wells are contaminated. We can't just simply say that if the groundwater level is very deep, then probably the chances of that water getting contaminated due to surface sanitation conditions is less. In fact, in this particular place only up to about 30 meters was weathered rock, and then below that they had fractured rock, and through the fractures the movement of the contamination could be much easier. So, if this contamination is not attenuated within this top 30 meters where they had the topsoil plus the weathered rock, and once it reaches to up to 30 meters, then it is highly likely that it would reach the groundwater however deep it is. So, both shallow wells as well as deep bore wells are contaminated. So, high levels of contamination due to open defecation, yes, public toilets and improper septic tanks, badly maintained drainage and septic tanks are also causing this high levels of contamination. In some places the wells are located in areas which are far away from open defecation and other surface sources of pollution, known surface sources of pollution. Those wells were also showing contamination, but we found that these supply wells are in locations where there is a high rate of pumping. There is the groundwater was being pumped from these wells at a very high rate, and the contamination which is occurring in recharge areas is reaching these places through groundwater movement. So, we cannot simply say that by improving surface sanitation conditions in one location we can improve the groundwater quality at that location. In fact, we have to go and then address the issue on a holistic manner. In the entire area we have to improve the surface sanitation conditions, not only improve the conditions of septic tanks, but we have to improve other surface sanitation conditions. Then we had selected some sites where we wanted to intervene in terms of septic tanks. There are some so called septic tanks were there, but then they were just simple leach pits. That means these are the septic tanks without any impervious bottom. So, there we said we would remove the existing septic tank, which is a faulty septic tank, and then put a properly designed and constructed septic tank. And in other locations we said we will not intervene, and then but we will monitor the quality of the seeping wastewater, or how it is interacting with the soil. So, this is like we had an existing septic tank here, let us say that is faulty. So, we put these pits here which are slightly away from this septic tank, like this 0.5 meters here, 0.5 meters and 0.6 meters, going to different depths. And then we collected the seeping wastewater from these the leachate pits or the leachate collection pits, and then we analyze them for the quality. What is the water, what is the wastewater quality that is coming in this, because that is an indicator of how much the loading, contamination is going to occur to the groundwater in that vicinity. And after monitoring, we intervene in some location, in one location, and we put a properly designed septic tank there, and then again monitored after installation of that, and then see what happens to this quality of this leaching wastewater into these leachate pits. In one of the areas where we had intervened by replacing a faulty septic tank with an improved septic tank, and until the construction, let us say we have taken the samples of this leachate from a depth of 7 feet, and before we intervene, this was the concentration of fecal coliform and total coliform at that location. For example, total coliform concentration was going up to as high as 4000, and then fecal coliform concentration was going up to 2500, and after we intervened, the concentrations have come down within that short distance of 7 feet, the concentrations have come down. Same thing we found that before the construction of this new septic tank, the concentrations were as high as 2000, and then after the construction of the septic tank at a depth of 10 feet, we can find that the loading of the contaminant into the soil and then eventually into the groundwater has come down. So, this indicates the effect of, or indicates to the level to which we can improve the situation by replacing this faulty septic tank or the leach pits, the conventional leach pits which people were using with a properly designed septic tank. We would be reducing the loading of contaminant to the ground. At a location where we did not do any intervention, you can see that throughout the period of our monitoring, the concentrations were more or less remaining the same. There is not much of a change in different at different depths. This is at 6 feet depth, and this is at 9 feet depth, and this is at 12 feet depth. You do not see that much of a change with time, okay, on an average. So, what are the key findings? The loading of contamination through leachate after constructing an improved septic tank in Ermaipatti has definitely reduced, and whereas same level of contamination has been found throughout the time period where we have monitored at a location where intervention has not been made. We also monitored the bore wells, the newly constructed bore wells. We had monitored in these newly constructed bore wells, what is the fecal coliform and what is the total coliform before the construction and after the construction. These bore wells are going pretty deep, and we can see that there is really not much change in the concentrations before and after the septic tank installation. Of course, we had monitored only for a year, but this indicates that by simply going and then improving the sanitation conditions now, we can expect miracles overnight, because once the groundwater is contaminated, it takes quite a lot of time to remediate that contamination. That we have to understand and then bear in our mind. And not only that, intervention at one location is not going to make any difference. Just there is a well, and then let us say we want to clean up the well, by just simply going and then improving the sanitation conditions in nearby locations, we may not be able to achieve that, because the contamination could be coming from somewhere else. So, that is the thing. Concentration of fecal coliforms in new wells is not affected by the concentration of septic tank, the construction of septic tanks. Now, highest concentration of course was found in a bore well located nearby the compost yard, and the contamination is due to infiltration of leachate in those wells is from solid waste compost site. We also did some what we call bacterial transport using Hydrus model for different types of, how the groundwater responds to different types of sanitation conditions are the practices, and then what we found was replacing the soak pits or leach pits with properly designed septic tanks will reduce the contaminant loading. Constructing toilets with proper septic tank constructing toilets with improper septic tanks or just leach pits contaminates the groundwater, in fact even more than open defecation does. That is a very important finding that we found. We found. And then types of overlaying, this is obvious. The types of overlaying soil layer has an effect on the nexus between sanitation and groundwater quality. Typically clay loam soils reduce contamination as compared to sandy soils. That means the interaction between the surface sanitation conditions and the groundwater quality is much stronger if in case of sandy soils as compared to the clay loam soils. And so, the key messages are constructing toilets in large numbers to eliminate open defecation may lead to large scale groundwater contamination if appropriate on site and decentralized treatment of wastewater is not carried out. The nexus between sanitation conditions and the groundwater quality is quite strong in the case of fractured rock aquifers overlain by weathered zone and fractures. Now, there is a significant reduction in contaminant loading from septic tanks if you can improve or modify the design of septic tanks, and the most important finding is attention should be paid to not only the faulty septic tanks, but also other sanitation conditions such as dump yards, compost yards, unlined and badly maintained channels carrying sewage, etc. That means, if I want to improve the groundwater quality in a particular area, it is not only constructing septic tanks and constructing proper treatment plants for wastewater treatment, but we also have to worry about other issues such as proper solid waste management. So, this particular lecture, as I mentioned earlier, is to demonstrate the interconnectedness when we talk about achieving something in the framework of sustainability. Thank you very much.